you turn your camera off, right?
Is it off or on?
I don't know. I can't actually see it. I don't see you, so maybe it's off.
Okay.
But definitely turn it off if it's not. I'm also going to open up. I'm going to actually see. I'll share my. I'm going to share my screen. Well, I'm sharing my um screen. Let's see. Are you able to share your screen in case I need it?
I don't think I can while you are.
Yeah, hold on. Can you see my calculator when I open it up? Can you see it now or no?
No, I can't see it right now.
Okay. So let me see. I'm gonna try to stop the share of this. Yeah, so the problem with Zoom, if I share my screen, um, so I'm gonna share my screen, but now if I try to open up, so when I share my screen, you can see my calculator now, right?
Yeah, yeah, I can.
Okay. But then when I open up the whiteboard, I think it's gonna turn that off. Unfortunately, the whiteboard doesn't allow me to share my calculator at the same time. So unfortunately, I got to do that separately. So let me see if I can open up the old whiteboard. All right. Anyway, if I need to show you my calculator, I won't be able to, is the point I'm trying to make. All right. So
Okay.
let's just get after these questions here. Now I'm going to start with this one. Number one, a cannonball that was shot upward. Can you see this okay?
Yeah, yeah, I have it in
Okay.
front of
Shot upward from a cannon with that equation. What is the height? So the highest the cannon ball will be above the ground. That's always going to be your vertex, right? So to find your vertex, you do negative b over 2a. That gives you the x coordinate of your vertex,
me. Yeah.
right? Which gave you that.
Uh-huh. Then you plug it
But then
into.
you plug that in to find the y coordinate of your vertex, right? So
Yeah.
plug this in for the x. Now, do you know the trick with your graphing calculator, the best way to plug it in?
Just put like parentheses around it or
Well, there's a store button. Again,
uh,
this is why I wish I could show my graphing calculator. But there's a store button in your graphing calculator. Let me see if I can
is it
show.
STO?
Yeah, the STO button.
Okay.
You see that?
Yeah.
So that, let me see if I can paste this now. Are you still with me?
Yeah.
Okay. Yeah, sorry, I can't see it. But that STO button, if you just type in, if you hit store, once you get that number up there, the 1.563, keep that whole number in there. And then
Okay.
hit store and then hit the X button. And then just type this in, but typing in X instead of T for that equation. And then it basically plugs that in straight in there. All right, that's a really good trick to know. So what is the highest? And then it says, how high is the cannonball off the ground? Well, off the ground is always your y-intercept, so it would be 35. Cannonball is attempted to hit a castle built on 175 feet above the ground. So you want the y value, the h value in this case, to be 175. So just solve this equation
Okay, so I got 113.125.
for part A.
Yeah.
Yeah, makes sense how you do that.
Yeah.
So for part C, you're going to just plug in 175 for h
175 for H. Okay.
because that's what the height that you want it to be. You want it to hit that height. See, this equation right here is basically an upside down parabola, right? And
Yeah.
you want to find out that height, you want that height right there to be 175. So you're plugging in, you're basically finding the x coordinate when y equals 175.
So
There's
when I write it, can I
175.
just move the 175 to the other side of that?
Yep. And then yep. So that's exactly what you do. To solve this, you would you would do that. Or if you can use your graphing calculator, do you know how to use your graphing calculator? to do
You
this?
do you just go to y equals and
Yeah,
then
you can plug y equals, you can plug this into y1, plug that into y1, and plug this into y2, 175 into y2, and find out where they intersect.
wait, so what do you plug into y1?
The
The multi
original formula.
okay.
See, look at my picture right here. This is exactly what I'm talking about. The that upside down parabola is your original formula, and then this is your equation y equals 175. It'll give you two answers, one here, probably left of, probably at a negative value, and then one at a positive value.
Now letting me put in the variable in the graphic calculator.
Remember, your variable is just x.
Oh wait, now it's working. Yeah.
Okay, that makes sense.
Yeah.
All right, so for number two, do you need number two as well for this one?
Number two, I got it. It's just the y-intercept, right? Or for B, I meant.
Uh, yeah, no, B, you already have that. C, we're already done with number one,
Okay.
all the three parts. But number two, I'm talking about. Do you need
Uh,
help with number two?
can you just use like matrices for that, right?
Yeah, yeah,
Okay. So I know how to do that then.
you're good with that. So
Yeah.
this is your x and this is your y. This is your x, this is your y, this is your x, this is your y. So you set up three equations,
Yeah.
and then
Yeah.
you have a matrix equation. Good with that?
Uh-huh.
Okay. So number seven, it says find a standard form of a quadratic that has the solution, that solution. Well, if it has that solution, it also has this solution, the conjugate, right?
Yeah, so
Okay.
the
So
conjugate.
have you learned this trick? Um, let's see, I think I might have written that wrong. Here's a little trick. Has your teacher taught you this trick?
I don't think so.
Yeah, I don't know why they don't teach this. This is really good. So think about if I told you that something had the zeros of -3 and +2, if those were the zeros, what would the formula be? It would be x plus 3 times x minus 2, right?
Yeah.
Which would equal x squared plus x minus 6, right?
Yeah.
So notice something about this. The 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 sum of my zeros, the sum of these is what?
-1.
And what's the product?
Is the product just
Multiply them. -6, right? So
yeah.
look at what I have here. This is always your product right there. And this is always the opposite of your sum.
Okay.
So look at my little formula here. The sum of the zeros goes there and the product of the zeros goes there. So if
Oh,
you know what your two zeros are, the sum, that's easy because these cancel and it's just -10, right?
yeah.
And the product is pretty easy too if you multiply these two together because remember they're conjugates of each other. So the inside and the outside will cancel out. So you'll just get -5 times -5, which is 25, and then -6i times -6i, which is -36i squared. And remember what I squared is?
It's -1.
Yeah, so this is really 36 plus 25, which is 61. So the answer to this question is just x squared minus the sum, and the sum is a -10, so plus 10x plus the product plus 61. That's your answer.
Okay.
Make sense?
Uh, let me give me a sec.
The other way you can do that is multiply it out longhand. which I can do that as well if we have time at the end. But that's a much easier way to do that problem. Okay, remember, this is being recorded so you can watch again later. Do you need
Uh,
number 8 or are you good with 8?
I'm good with 8. Uh, can you go over number 3 on the first page
The
that we were
first
doing?
page? Yeah,
Yeah, it's the basketball problem.
yep. So number 3, Jeremy is shooting a free throw. He stands 15 feet horizontal from the backboard. Okay, so 15 feet. So that's 15. Here's the backboard. Here's Jimmy or whatever his name is, which means he is 13 feet from the front of the rim. So the front of the rim stands out like this,
Yeah.
2 feet. It must stand out 2 feet, right? That's 15 right there. But this is 2. So really, this is 13, and that's 2. Got it?
Yep.
He releases the ball from his hand at a height of 76 inches. So this is 76 inches. So notice, first of all, they're different. These are feet and the other ones are inches. So let's keep that in mind. The rim is 1.5 feet in diameter. So 1.5 feet in diameter and 10 feet above the ground. So this is 10 feet, 1.5 feet in diameter. Okay, so this distance right here, see, the rim is 1.5 feet in diameter and 10 feet above the ground. So I'm assuming that this is 6 inches, the little part that attaches the rim to the backboard. Is that 6 inches then? Am I assuming that correctly?
I don't think we were counting that in when we were doing it.
Well, because they're saying the rim is 1.5 feet in diameter. But remember, they already said he's standing 15 horizontal feet from the backboard, but then it's coming out of the backboard. 2 feet
Oh,
is what I'm assuming, but they just said 1.5 feet. So that must mean that this, if you're looking at the rim, the little piece that connects it to the rim, that must be 6 inches,
oh yeah, I think that is then. That makes
right?
sense.
So this is 18 inches here, a total of 2 feet here. That makes sense?
Yeah.
Jeremy shoots the ball and is headed in the direction of the rim and does not miss sideways. If the vertex is 7.5 feet from where he shoots the ball, shoots it, and 100 that many feet above the ground, is the ball likely to go in? So we've got a vertex h comma k. So our formula is going to be, we're trying to figure out if when he shoots the ball, we want to make sure that distance, we want to find out basically what the distance is for when it's like at 10 feet in the air. We want to basically find out how far this distance is when it's 10 feet in the air. You know what I'm saying?
Yeah.
So we got to come up with a formula. They told us that the vertex, so let's see, y equals um, a times x minus h squared plus k.
Yep. And then,
And we know h is, let's convert everything to inches.
yeah, we can do that.
Okay. So let's see, 13 feet from he released the ball. The vertex is 7.5 feet. So 7.5 feet is 12 times 7 is 70, 84 and a half. 84 plus 6 would be 90
Yeah.
inches. Okay,
Yep.
so 90 comma 143.6. Okay, which is 90 feet from where he shoots. So 90 is the H, right?
Yeah. And then 143.5 is the K.
We don't know A. 143.5 is the K. We don't know why, but we do know the when he shoots the ball, it's 76. So 76 comma 0, sorry, 0 comma 76 is another point. So to find A, let's plug in 0 comma 76 and then solve for A. Did you do that already?
I'm doing it right now.
Okay. I'm going to do it on my calculator, which I wish you could see, but that's okay. 76 minus 143.5 divided by 90 squared. So A equals negative 0.0083, repeating, where the 3 only is repeating. So that's A. And now we're trying to figure out what at what point it reaches 10 feet or 120 inches. So now we plug in 120 for Y. Keep that A right there. That's my A. So just use that in your calculator. X minus 90 squared plus 143.5. So solve that equation now.
Okay.
I'm storing that for X, by the way. That's the trick. You can use that store X button, that A, the value for A, store that for X. So 120 minus 143.5 divided by X. That's 2820. Take the square root of that. And then add 90 to it. You get how I'm doing this? Are you doing that as well? So
Uh,
X would equal 143.10366722.
Wait, so would you move the 120 to the other side, or would you move?
So no, I subtracted this to the other side. Remember, we're trying to solve for X. So move
Oh,
that to the other side.
all right.
So you get negative 23, you get negative 23.5 equals A times X minus 90 squared, and then divide by A. And dividing by A gave you 2820 equals X minus 90 squared. Then take the square root of both sides and then add 90. So it's the square root of 2820 plus 90, which is approximately 143.1. So now so that means it's going to be X is going to be one. Let's see what we find. Yeah, X is going to be 143.1. That's the distance. So what is 13 times 12 is 156. So this was 156 inches. It's between 156 inches and add 18 more inches to it. It had to be between 156 and 174 for it to go in. And it was at 143, so it's going to come up short. Got it?
I'm still doing it.
While you're doing that, I'm going to show you the last one. Did you need help with this number 1 here? Or number 3? Which one was it?
On the non-calc part?
On the first one, yeah, the graph.
Uh,
Yeah,
yeah, I needed help with that one. Number
with
one.
number 1.
Yeah,
Okay.
I just wanted to make sure if that was right, what I have.
Oh, what you have? All right, so you did negative b over 2a. So negative 18 all over 2 times 3, so that's 6. So when you cancel and cancel, that's negative 3. And then when you plug negative 3 back in for x, again, use your calculator with that store button.
Yeah.
That's just the easiest way to plug it in. So 3x squared plus 18x plus 22 negative 5 is what I got.
For the y.
Yeah. And I'm going to graph it just to find out if I was right. Your graph, I think, is sitting up too high.
Uh, um,
Yeah. Yep. Should be down. Should be down here at negative 5. That should be
okay.
your graph. That should be your point right there. And then your y, your x-intercepts, they want the x-intercepts as well.
Okay, so I'll
Yeah.
switch that.
The x-intercepts do exist because if you use a graphing, if you used our quadratic formula, remember your x-intercepts, you can use quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. And 18 squared, 18 squared minus 12 times 22 is positive 60. So it is a positive number. So you are going to have 2 zeros.
Okay.
Got it?
Yeah.
So those are your answers right there.
Okay. Could you go over number two also from below?
Mm-hmm. For this, solve x, allowing for complex solution. So for this one, I'm going to subtract 1. Whoops. Sorry, hold on a second. Zoom in here a little bit. 2x minus 5 squared. Divide both sides by 3, so it's negative 3. 2x minus 5 squared. Now to get rid of the square, I have to square root both sides, and don't forget the plus or minus when you do that. Okay, got
Okay.
it. Now I have to remember this means like square root of 3 times I, right? So 2x minus 5 equals plus or minus I square roots of 3 is how they probably want you to write it. Now I'm trying to get x by itself still, right? So I have to get rid of the 5. So 2x equals 5 plus or minus I root 3. And I'll get rid of the 2 by dividing. X equals 5 plus or minus I root 3 all over 2. Those are your 2 answers.
Okay. Thank you.
Notice how this was in vertex form, so it was easy to solve that one. As opposed to this one, which they want us to write complex solutions. So you can do either quadratic formula, factoring, or completing the square. Are you good with completing the square?
Yeah, I'm pretty sure I know how to do that.
It is a little bit trickier to complete the square in this one because of the 4 in front, but if you know how to do it, it's the easiest way to do it. Or if it factors, that's even easier. And you're saying that it does factor. Huh? Let's find out if that works. Negative 3x, positive 16x. So that'd be positive 13x. Yep, that's right. Yep, yeah, that worked. So it does factor. So it looks like you got that one right.
And then it's
You good with
four, all right?
you good with number 4?
I think I got it right. Can you check?
Find x when f of x equals 32. So I'm plugging 32 in here and then just solving. So subtract negative 36. And you can check these by using your graphing calculator
Okay.
by plugging it into the store button as well. So like plug one of those in for x and then use the store button and then rewrite this equation and see if you get 32 as your answer.
Okay.
And that's a good way to check your answer.
All right.
All right. Sound good?
Yep.
All right. You'll be able to watch that video